Hi and welcome to this tutorial. We're going to start in on control signals, communicating our physical controllers using the Arduino board, hooked up like faders and buttons and such, connected to our Arduino board, and we're going to pipe it into Supercollider. Now I did a whole kind of playlist, a series of tutorials showing you the ultimate Arduino framework of inputs. That's my hyperbole, that's what I'm calling it. But basically it's a nice tidy sort of system where you can get a lot of different types of simple controllers all in the same sort of basic architecture, basic code, and just with a few modifications just adapt it for your particular rig. Okay, now I'm going to show you the Supercollider side of it, and this kind of a similar approach, at least in logic and in thought and structure, can be applied to different programming languages, but obviously not the specifics. I'm going to work here in Supercollider and show you how to get those messages in. I've done a number of other tutorials that are probably similar to this. This is maybe a little bit redundant, but you can check those out as well. That might be helpful. But I'm going to try to kind of be very systematic about showing you how to get control signals in, and then you can just take your old MIDI keyboards and faders and stuff and chuck those in the trash. Well, don't do that. But this does allow you to make very customizable controllers for pretty cheap, and gives you a higher degree of resolution for controlling audio processes. And then you can do very customizable kind of things that suit your performance style or whatever you do for a digital audio. Okay, let's get started then. So first of all, we're going to do a serial port list devices. Okay, and that'll show us what things we have available. All right, and then we're going to start our Arduino. We'll just make a global variable here called INO, and we'll make it equal to Arduino SMS. Oh yes, of course. Let me go ahead and take care of this now. If you don't have this installed, you can, I think there's already a tutorial up there. I might just add that to the playlist anyways, but I'll describe it here, might as well. It's very easy. You can use the Quark system, so QUARK, quarks.GUI, I think that's it. And then it'll bring this GUI up, and then if you just check Arduino here and then hit apply, that should automatically install it for you. And then you'll have your Arduino SMS installed. Okay, so we're going to have Arduino SMS, and then the port name is going to be that thing we printed out here, that devtty. I recognize that as the thing I have installed. Okay, and then the baud rate 9600, whatever baud rate you used for your original Arduino code. Okay, and then so then very simply now you have then ino.action, and then you use an equal sign instead, I think, and I believe it's a, is it a function? I think it's a function. Let's just do msg as an argument there, and then just msg.post ln. Oops. I believe that's it. So if I start my Arduino there, it says an Arduino SMS. That's good. If I hit the action, okay, so it's going to print out. So I have 7 pots and 7 buttons. And again, just refer to my previous set of tutorials if you don't understand what this is. But my Arduino is now printing out to the serial port, and it's coming in through this Arduino action every time I make a change or I add some kind of data there. Okay, that's very handy. All right, so now let's make this a little bit more sophisticated. We're going to go ahead, and you notice our messages here have that header, and then this colon is a divider, and then we have the 2 parts, and then the data that comes with that. So we can identify each of our controllers based on this header we installed. So that's why that's quite handy. So let's break this out a little bit. Okay, and then we'll create some variables here. We'll say var, and we'll call it header. Okay, and we're going to equals to msg, and it's the oh sorry, sorry. So first we're going to split it by that colon. Okay, so we're going to do well, we'll just call it message split, MSG split. I forgot what I called it before. Equals, it'll be split MSG, and then we're going to use a $sign to denote the symbol. It means that we're going to use the colon as a symbol, as a delimiter. Okay, so and so let's just do MSG split. Let's see what happens when we do that. We'll run that action. I think I can just override the action. Okay, so now every time I do, so you get an array. You see down here an array with the header on the left and then the value on the right. Okay, so now it's a nice array. MSG split is a nice array. So we're going to do var, and we're going to make a variable called the header. Okay, and then there must be easier, shorter. We'll just call it the tag. Do you understand that? Hopefully that's understandable. And equals split. It's MSG split. Okay, 0, right? That's the right side of it. And just to be super cautious and all, we're going to make this. Should we make it a symbol or a string? Why not? We can make a symbol as, because they're all contiguous. So as symbol. Okay, let's do that. Okay, and then var data or val, we'll just call it val, equals MSG split 1 dot as, we'll make them all floats, though sometimes they're integers. Okay, so I hope you understood what happens. This message comes in, the Arduino action invokes, we start the Arduino, and then Arduino action invokes that, says that every time we receive any kind of data from our Arduino, basically from the serial port, right? So you can see that P2, I'm changing my, it's going to come in as this, it's going to come in as this string, right? It's going to come as this string, PO colon pot 0 colon and then the value. Okay, now I'm going to split it here using this command split into an array. So the left, and using the colon delimiter, saying that it's going to look for this colon and it's going to split it into, every time it sees the colon, it's going to make a new index in my array. So then the message just only has the left side of the colon, the right side of the colon. It's going to split into an array of 2 things. So message split, right? It's going to split it into 2 things. The left 0 slot will be the header, and the right slot will be the value. Okay? And then I just broke those out into variables. The tag or the header, well, I'll just call it the header. It's just a lot to type later on because we'll use it quite a bit. The header will be a symbol, and it'll be the left-hand side. So in this case, P5 for my pot 5. The right's, the val will be message 1. Message split 1 will be the value or the float that comes in. Okay. So then now it becomes eminently more useful. And we can use this kind of as a general framework now to bring in all our values into Arduino, into Supercollider, okay, from our Arduino. Now, what we need to do is we need to parse for. So right now I'm just going to do one pot and one button, just to show you just the basic, and then maybe the next one I'll start building a more comprehensive sort of expandable structure, just like I did with the Arduino, kind of ultimate Arduino framework, as I call it. So what's going on here? We're going to do, we're going to look at the header and then see if it corresponds to a certain thing that we're looking for. So in this case, we're looking for, say, P0, okay? Because that's my pot number 0. And so we're going to say if the header equals, okay, and then we'll say P0 because that's the header I signed in Arduino. Then we'll just print the value. So we'll say val dot post ln. Okay. So now we'll only print the value if the header's pot 0. Okay. So let's evaluate that action. Okay, now I don't have this on camera, but I'm moving a bunch of other faders and they're not going. But when I get to P0, oh, it's not working. Okay, let me figure out what's wrong. Because I was silly and I said symbol, so just because I thought that would be easier on me, and you could use those like in dictionaries and stuff like that. I thought maybe a good. So we're gonna make it a symbol, huh? Instead of a string. Okay, so that should work there, and it does. So that's my pot 0. But if I move the other pots around, nothing gets done. So this here, if header equals, is going to parse for my P0. So only pot 0 happens here. So this is put in is pot 0. So everything happens in this function right here. So I can, every time I get a value from pot 0, it'll run whatever's in here. So I can do any number of things. I can use that to set some kind of frequency or something like that. And then we'll do one button here. Okay, so we'll call this button 1, 0, button 0. Okay, and the same thing. So we'll just copy it all. And remember, the value is the actual value coming in from that particular message. So if the header is equal to B0, that's my button, then the value of that post line. Okay, so we'll go ahead and evaluate that, and then I'm hitting various other buttons. But finally, when I come to button 0, it's going to give me 1, and those are just readings from my pot, straight pot 1, 1, 1. Okay, and then button 0, and then we have a toggle button as well, so we might as well put that in as well. Okay, button 0 toggle. Okay, and I think that was just called BT0. Okay, and then we'll go ahead and evaluate that. And then, yeah, that's 9, 1, 1, 2, 3, 4. You see that 5. I think I put it 10, 6, 7, 8, 9, and then back to 0. So that's the toggle. Okay, so basically you have these 3 things that we can do from just one button, one slider, and you can do various things. So let's quickly do a testy kind of thing here. So I'll just chuck this in here somewhere. I'll chuck a tester synthdef. I should have saved it from a previous tutorial, but we'll just do it very quickly. So def synthdef, we'll call it A to SC test. And then we're going to have an argument, a couple arguments here. We need our function. We're going to have freak, and we're going to have, well, let's just make a proper thing. So test, we're going to have args. Just bear with me here. I'm just kind of trying to do a quickie synthdef, but I want to be able to use the various things. So we'll have arg freak, and we'll have a var env. Yeah, that should do it, hopefully. And env will equals envgen dot ar. We're going to env dot asr. Let's just keep everything the 1 bit, and we'll have a gate, and then like that, and we'll have a gate here. Okay. All right. We'll just start it at 0 actually, and this will be out. It'll be 0. It'll be sign os AR freak, and it'll be times the env. Okay, so that's pretty quick and dirty there. All right, and we'll use our node messaging. I had put on a earlier tutorial there for node messaging, so if you're not familiar with this kind of node messaging, though I already kind of blew it with, I didn't blow it yet. No, I guess not. Well, anyways, we're going to use node messaging to start a synth here. So we'll have this s.send. Something's wrong with my, I forgot a bracket or something like that. All right, this is .add. Okay. Still something's wrong. Oh, it's all within the action. So you want to close that action there. You don't want that in the action. Okay. Do I have an extra thing there somewhere? No, maybe? I don't know. Not sure. Okay, there we go. Okay, so that's the Arduino action. Ends there, and then our synth def. And then we'll have we use node messaging to start a synth, so s.send msg, and it will be snew, or yeah, s_new, and we're going to have a to sc test, and it's going to be at node say 3000. It's going to be this 0 tag, and we'll just add to the group 1. And we'll have gate, it'll be 1. Or we won't have gate 0. We'll just start it up there. Okay, so hopefully, are we booted here? We are. And let's see if this adds. Does it? It adds. And let's see if this goes. It does. Okay, so we have it running now, and then what we're going to do is, this was just to get all that, just to get a simple sine wave running. But since the gate is 0, the envelope is off, so that's why you're not hearing any sound. And so we're going to update our action now, so that every time I press the button, the toggle button, for example, we'll have this button. Okay, if I press it, it's going to be a 1 or 0, right? It's going to come in, the value is going to be 1 or 0. And we'll just have it turn it on or off, the gate on or off. Okay, so we'll just use a if statement here then. Okay, so we'll say if val is equal to 0, for example, then it will be, and we'll use node messaging again, s.send msg n_set. We're going to set the mode 3000. Okay, because that's the thing. That's the test. It's at node 3000. The synth has been started there. And we're going to set the argument gate. And this gate will be 0, because if it's 0, it will be 0. Actually, it's inversed, right? So 0, this will be gate 1, because high is, or did we flip it already? Gosh, I forgot. Well, I think we did flip it. So that'll be 0. Okay. And oops. So yeah, let's end that. And then else. So if it's 0, that means if I'm not pushing the button, it'll send this there. And then if I am pushing the button, if it is 1, or it's not 0, but there's only 2 choices, then we'll do the same thing, s.send message, except we'll make it, let's shrink that so you can see everything on one line. We'll make this gate 1. Okay. And then we'll close our if statement. And I think we need a semicolon. I don't think we need one, but I'll put one there anyways. Okay. So then now if I evaluate this whole action, if I hold the button, it should come out. Oh, it's not working. So my problem was I just didn't add a frequency here, so I went ahead and did that because it was just frequency nil. So now when I push the button, it plays that thing, and then I let go, it gates off the envelope, right? So if I push it, it's gate 1. I'm holding it open. If I let it go, gate 0, it releases the envelope. Okay. Now we can use our pot to set the we can set the frequency of it if you want. So we can, in this pot 0, we can say basically now the val is going to be modulated here, right? It's going to be some value between 0 and 1023. We don't necessarily want to make that the frequency, so let's go ahead and map it. All right. So we'll do again node messaging s.send msg. We'll do node.set underscore set. It'll be 3000. We'll set the node 3000, which is my A2SC test here, that sine wave. And we're going to set the frequency, but we're going to set it not to val, but we're going to say, we're going to map the val. So we're going to do val.lin. Okay, that's a mapping function. And it's going to map from 0, we said, to 1023. And it's going to map, say, the frequency, say, from 300.0 to, say, 1000, which is not too far. Okay, so we'll do that. Right, so it's going to set that frequency to between 300 and 1000, depending on where my slider is. Okay, so let's reevaluate that action. Oops, button 0, blah, blah, blah. Okay, s.send message. All right, I don't have a closing bracket here. Okay, let's do that again. Okay, so now I'm moving my slider. Okay, so that's my slider now controlling the frequency. And so you see kind of the basic idea now is we're adding some kind of function in here every time we get some information. So this is a main where all the business happens here. Parsing for these headers. Okay, so the last thing I want to show you with this tutorial, and then we're going to kind of reconfigure everything a little bit because there's kind of a more efficient, I guess, way of doing things. So we're going to reconfigure some of these things, but just so you can see the basic concept, the architecture, the way it comes in. Things come in, we get split, we split the message, we get a header and a value, and then we just parse for each of the headers. We see what they do. Now the next thing I want to do, or the last thing I want to show you, at least in this part, is now instead of directly changing one synth, we're going to make it so that you can change any kind of synth. I just have the one test synth now, but we're going to make it so you can, by using control buses. Okay, so any of our continuous values, maybe the buttons not so much, we'll address those later. But the continuous values, we're going to have, we're going to set them, we're going to put them into a control bus. Okay, so we're going to throw those values into a control bus. So let's go ahead and make some buses here. You can use node messaging if you want, so you don't actually have to set the buses themselves. There's a command. You don't have to actually create buses. You can just, and I think the command is C something, that's it. So when this comes in, I'm just going to actually set the raw values into the control bus. Now, every time we bring a value in with one of our pots, or just with our pot here, we're going to set a control bus. Okay, and so the command for that is s.send message msg, and I believe it's c underscore set. And then you just give the control bus number. So let's just make this, we just have to have kind of a legend. We have to memorize which things we're setting. So our pot 0, we'll just set control bus 0. Okay. Oh, and then what value? Let me just double check that. So C underscore set, and it is the one and then the value. Yes. Okay, so we're going to set bus 0 with a value, the val that's coming in. Okay, so we're parsing for this header P0. Once we establish that it's the value is coming in from our pot 0, we'll use that value, and we're going to set this control bus 0. All right. So now it's kind of just like a patch bay or something. We're setting all of our sending all our control signals to a bus, and then we can use those later. All right. So let's go ahead and evaluate that. I don't think I mucked up anything here. Okay. I'm going to go ahead and free this. No, I won't. Let's see. Let's see if my button's still working. Yeah. Okay, except my fader is not. I'm moving my fader, but it's not doing anything there. Okay. But what we can do is we can map that now. So we can map this. We're going to do s.send msg, and we're going to map now our node. So this is n underscore map, and we've done this before just using the old sort of system. It'd be like a.map if a was a synth, and it'll be node 3000, and it will be the control freak will be mapped to bus 0. Okay, so if we do that, that's changing our faders, now changing our thing. Now it seems like an extra step, maybe unnecessary, but when we have multiple synth defs and a lot of different things, this becomes really handy. And I'm going to show you some more things to do with that as well. Okay? And we'll have a different system for the buttons, but we'll get into that in the next tutorial. So let's just wrap this one up. This has been kind of a long one. And eventually we're going to build kind of a framework that's going to let you call it then the ultimate sort of control signal framework. It'll be a little involved, but it'll allow you to take, have a very, very flexible system to allow you to map and do different things and to use your various controllers with a lot of different synths. Okay, so let's go ahead and just sum up what we've done so far and point to see where we're going with part 2. Okay, so right now I just set up this basic framework, and the basic idea here is that we have our Arduino. I showed you that. You bring this in, and then you have this Arduino action, and everything happens in this Arduino action, right? And the basic idea, and we've kind of beat this dead horse a little bit, but I'll go over it one more time. The message is coming in, and we've configured that specifically with our Arduino code. So it has a header and the colon, and then it has a value. And we're splitting that by the colon so that the left-hand side, message split 0, is the header. And we made it a symbol this time. That becomes a little bit more convenient later, and I'll show you. And then the right side is the value, and that's going to be making it split 1. Okay, so a value and a header. And then we just have a list of if statements, which will kind of change slightly later on. Maybe not that much, but anyways, change slightly later on. But in any case, we're just using if statements to parse for these headers. So if the header is P0, then run whatever's in this function there. You can do anything. Just every time you get a value from P0, this is what it will do. Okay, and then we have if header is the button 0, then here we had that's what it does. And if here it's the toggle, same button, but it's the toggle value, this is what happens. Okay, for each of the individual pieces of data that come in. And then we saw that we could look at, for example, the button and see if it's on pushed or not pushed. And then we created a test synth, sine wave synth, and we're having it set the gate. So every time I push the button down, it turns the gate to 1. It starts the sine, opens the envelope. And if I let go of it, it releases the envelope there. So it turns it on and off. And then the final step there was I showed you how to just map directly this to frequency. But a better way is to set a control bus. So control bus 0 here is being set using this node messaging, and it's being set with a value. All right. So then we have no matter what we're doing with our faders, they're going into these control buses, and we can use them to control a lot of different things and map them in different ways. Okay, so it's a lot more versatile to use control buses here. And then we mapped it, our synth, to that bus, which is this bus 0. And so then it worked to control our frequency. We mapped our synth 3000 at node 3000. We mapped its argument frequency to control bus 0. Okay? And there you go. Okay, so let's end that there. I hope that was useful to you. Maybe a little bit long and a little bit wordy, but that's okay. And we'll continue on. So the next time, what we're going to do is we're going to try to break out this framework into kind of a more whole form that that becomes slightly more complex, but also allows you to, use it with a lot more flexibility and bring in a lot more different things. So we're going to change kind of the structure here a little bit, so you can have like one chunk of code that will take in all kinds of different headers, et cetera, and then when you want to change your rig, you can update this very simply, a lot like what we did with Arduino code, very similar way. Okay, so stay tuned for the next one.